Hello, thank you so much for watching us once again. I'm so delighted and happy that you're following these lessons. I'm very sure you are learning a lot from it. And those who have just joined us today, I request that you click the red button and you subscribe to this channel so that you can get more notifications. We have series of videos here, and I request that you don't miss any of them. In case you already missed, please go back and watch them so that you can see the beauty of how the lessons are flowing. I still remain your teacher Alira Daniel. I handle physics and mathematics. We have been discussing waves. Well, we started from the introduction of waves. We said wave is any disturbance that transfers energy from one point to the other point without permanent displacement of the wave particles. We said waves are categorized into two: mechanical waves and electromagnetic waves. Waves can also be classified into transverse and longitudinal. Waves may be progressive or stationary. We went through sound waves. After going through the sound waves, we went through ultrasonic sound. And today, we are discussing waves in a vibrating string. As we are already aware, we placed waves in a vibrating string under one, progressive wave, but not only progressive wave, but also under transverse wave. So waves in a vibrating string is a transverse wave. That's what we need to know about wave in a string. Now, for us to understand very well wave in a vibrating string, we can first determine the frequency of a wave produced in a vibrating string. So today we are going to see the factors which affect the frequency of a vibrating string. When a string is vibrating, what determines its frequency? We define frequency. We say that frequency is the number of complete oscillations that a wave makes in 1 second. So if a wave makes 20 oscillations in 1 second, that means that this frequency is 20 oscillations. If it makes 50 oscillations in 10 seconds, that means that its frequency is actually 5 Hertz. So that is when it comes to frequency. Now, a string, when you pluck a string from the middle, when you have a such string, and then you pluck it from the middle, then actually it will produce a transverse wave made up of crest and trough. Now when you pluck this string, it will produce something like this. Now, this is a complete oscillation. This is a complete oscillation. This is a complete oscillation. Those are 3 oscillations. So the number of oscillations made by this string depends on basically 3 factors, which we are going to discuss in this lesson. The first factor is the length of the string. So among the factors which affect the frequency of oscillation of a string is the length of the string. Then the second factor is the tension in the string. Length of the string is the first factor. Then the other factor is the tension in the string. Then the next one is the thickness. Oh my God. Thickness. Or sometimes this can be called as mass per unit length. So these are basically 3 factors which affect the rate, which affect the frequency of oscillation in a vibrating string. 1, tension in the string. 2, length in the string. And then 3, the thickness of the string, or the mass per unit length of a string. Good. Let's talk about the length of the string. How does the length of the string affect its frequency? If you have a string which is long, like this, then you pluck it in the middle. Do you observe how the wave can be moving? The speed at which the wave moves? What about if the string is just it's short like this? Then you pluck it in the middle. Do you observe how it moves? You realize that if the string is shorter, then it moves a little bit faster. I don't know whether you realize that. Please do that practically and you see. But if the string is shorter, then it moves a little bit faster. That means that it also makes more oscillations than when it's what? Long. So the shorter the length of the string, the higher the frequency. And the longer the length of the string, the lower the frequency. So we come and make a conclusion that actually the frequency of a vibrating string is inversely proportional to the length of the string. Oh my God. The frequency of a vibrating string is inversely proportional to the length of the string. We write that mathematically. We say F, which is the frequency of a vibrating string, is inversely proportional to the length L. This is the mathematical expression. We're saying that the frequency of a vibrating string is inversely proportional to the length. So we say F is inversely proportional to 1 over L. So that is that. Now, we remove this proportionality sign, and then we introduce what we call the proportionality constant. Proportionality constant goes together with an equal sign. So we shall have F to be equals to constant K over what? Over L. If we multiply all through by L, we shall get FL to be equals to a constant what? A constant K. Now, in physics, we interpret this again in a different way. You see, physics doesn't see things in the perspective of other subjects. For it to see things in its own way. I like physics because of that. There's nothing physics cannot explain. Physics, you can say that this board is black, but physics will tell you that it is not black. That is physics. What's the color of the board? Black. No, it is not black, my friend. The color of the board is not black. And now the question is, what's the color of the board? The color of the board appears to be black, but it's not what? It's not black. Why? We are saying that if light falls on this board, it absorbs all other colors. If white light falls on it, white light is falling on it. If white light falls on it, you know white light has all the 7 colors. The red, yellow, orange, blue, white, and white. So if it falls on this, it will absorb all the 7 colors and it will reflect none. So by reflecting none, you see nothing else but a dark color or a black color. That is physics. I like it when it comes to explaining the phenomenon. It explains very many things. I like physics because of that. So it sees this in another perspective. FL equals a constant what? Constant K. So if we talk about FL equals a constant K, which is a constant, to physics, it says that if I say A equals to a constant K, then that means that A1 is supposed to be equals to A what? A2. If I say PB equals a constant K, that means that P1, B1 should be equals to P2, V what? V2. That's the implication. So if A is constant, that means that A1 is equal to A2 equals to A3 equals to A4 equals to A5. That is the interpretation. So here we are saying that FL equals a constant. This implies that F1, L1 should be equals to F2, L2. This is the expression that relates the frequency of a vibrating string with its length. F1, L1 should be equals to F2 L2. This is the one. But on condition that you have kept other factors constant. Remember, we have other factors. We have mass per unit length and tension in the what? Tension in the string. So if we keep tension in the string constant, mass per unit length constant, then F1 L1 should be equal to F2 L2. Good. We have an example on the board here. I want us to try and see whether we can manipulate and break it through. A string has a length of 15 centimeters and vibrates at a frequency of 200 Hertz. So we have a string of frequency, of length, that is length L1 in my solution. We have a string has a length of 75, that is L1, which is 75 centimeters, and yet it vibrates at a frequency 200. So that frequency corresponds to this length. I call it to be F1 also 200 Hertz. What will be the frequency if the length is increased to 100? So they want the new frequency if the new length, which becomes now our L2, is increased to 100 centimeters. Now, one thing which I want to ask you about is, will F2 be greater than F1, or F1 will be greater than F2? Can we reason that out? The frequency F2. Remember, they have increased the length from 75 to 100. So what will happen to the frequency? Is it going to increase or it will reduce? From the statement which we had just made, we said that the frequency is inversely proportional to the length. And so if you increase the length, you are reducing the frequency. So we expect F2 to be less than what? F1. Good. So let's move on and do this calculation. So we are saying that if we keep other factors constant, then F1 L1 should be equal to F2 L2. So our F1 is already 200 times L1, which is 75, should be equal to F2, which we are looking for, times L2, which is 100. So we say 200 times 75, that is 1,500. That is 200 times 75, it is 15,000 actually. 15,000 should be equal to F2 times 100, that is 100 F2. So you divide all through by 100, all through by 100. So our F2, this addition will go, F2 is going to be 150 Hertz. So this is the frequency of this vibrating string when its length has been increased to 100 centimeters. The frequency will reduce from 200 to 150 Hertz. Any question, please? Get into the chat box, the live chat. Type there. I will answer it right away if you have not understood anything here. Or you can contact me personally on the number 070-375-0387. In case you have not understood anything here, please contact me on that, or just get into my live chat. I'm there, and you ask your questions. I'll be in position to respond. But that's how it is, as simple as that. Let's look at e.g. number 2. A string vibrates at a frequency of 300 Hertz. What will be its frequency if the length is doubled? Oh my God. I like that statement, if the length is doubled. And which length are you doubling? We have not been given. We have not been given that length. And they're saying that if the length is doubled. And now, what are we doubling? We don't know. The length is not given to us. But that shouldn't be a problem. If the length is not given to you, let it be x. So a moment it's doubled, that means that the new length will be 2x. Is that okay? So the initial length, we don't know it. But they say it's going to be doubled. So I let the initial length to be x. And then when it's doubled, that means the final length will be 2x. As simple as that. Good. Let's say a string vibrates at this frequency. So when it's vibrating at this frequency, let's say the corresponding length is x. So if the frequency is 300 Hertz, F1, I will say L1 is x. What will be the new frequency if the length is doubled? So if initially the length was x, then finally, this time round, our length is going to be 2x. Remember, it can be tripled, it can be increased like 4 times, 5 times, so you multiply by that. So we say from F1, L1 to be equals to F2, L2, F1, 300 times x should be equal to F2, which we are looking for, times 2x. So this is 300x. 300x should be equal to, this is 2f2x. Then I divide all through by 2x. Remember, I want to make f2 the subject of the formula. I divide all through by 2x, then all through by 2x. So x here will go with this x, this 2 will go with this 2, this x will go with this x, then by 2 you get 1, by 2 you get 150. So finally our f2 will be 150 Hertz. So that will be the new frequency. Okay, please check well. I need to give you a trial question. You try this and see whether it comes out easily. Good. Our trial question is here. A string vibrates at a frequency of 250 Hertz. If the length of the string is increased 5 times, what will be the frequency? Please try this out on your own, and I believe it will easily come out. I thank you once again for watching this lesson. I believe it has been a blessing on your side. And in case you still have queries, please feel free. We are here for you, not for any other person. You can contact me personally, or you type your questions in the live chat. For now, let's stop here. We shall continue from here in the next lesson and in the next video. Please endeavor not to miss. Goodbye for now. See you. Goodbye.